What is the sum of the first 25 terms of positive 7, positive 12, positive 17, and positive 127 as the last term? So the formula to get the sum of the arithmetic sequence is S of n equals to n divided by 2 multiplied by the sum of the first term, which is a sub 1, plus the last term, or a sub n. Okay, so in our given here, our n, or the number of terms, is 25 because of the 25 terms. So our n here is 25. And our a sub 1, or our first term based on the given, we have positive 7. So our a sub 1 is positive 7. And then our a sub n, this is also equal to a, since our n is 25, so this will be a sub 25, or a sub 25. And our last term here is positive 127. So just using this equation, as our n is 25, so s sub 25 will be equal to n. Again, our n is 25 divided by 2 multiplied by our first term, or a sub 1, which is 7. Okay, our a sub 1 is 7. So this will be 7 plus our a sub 25 is 127. Okay. So our s sub 25 now, this will be equal to 25 divided by 2. This will give us positive 12.5, and multiply this by 7 plus 127. This will give us positive 134. So our s sub 25 now will be equal to 12.5 multiplied by 134. This will give us positive 1675. So s sub 25 now is equal to 1675. And this is our final answer. What is the sum of the first 6 terms of 1/2, positive 1, and 3/2? So to solve for the sum of the sequences, we have the formula s sub n is equal to n divided by 2 multiplied by a sub 1 plus a sub n. Okay, so our a sub n here, so for our given, our n here, or the number of terms, we have here, based from the given, we have 6 terms. So our n will be equal to 6. And then our a sub 1, or the value of our first term, this is positive 1/2. So we have here positive 1/2. And for our a sub n, now since our n is 6, this is now written as a sub 6. But we do not know the value of a sub 6, so our a sub 6 is the unknown. We have the formula to find for a sub n, or a sub 6. So this will be a sub 6 equals to a sub 1 plus n minus 1 multiplied by d. We have first to find for the value of d. So d now, this is just the difference of 2 consecutive terms. So we may use 3/2 and 1. So 3/2 minus 1, this will be equal to, okay, 3/2 minus 1, this is equal to 1/2. Or we may also use 1 and 1/2. So 1 minus 1/2, this is still equal to 1/2. Now, let us now substitute the value of d to our a sub 6. Our a sub 6 here, this will be equal to, the value of a sub 1 is 1/2, plus n, which is 6, minus 1, and multiplied by d, which is 1/2. So our a sub 6 will be equal to 1/2 plus 6 minus 1 is 5 multiplied by 1/2. So our a sub 6 here will be equal to 1 over 2 plus, so 5 multiplied by 1, that is 5 over 2. And if we add this, we will just copy the denominator, and then 1 plus 5 equals to 6. So our a sub 6 is positive 3. We can now find for the s sub n or s sub 6. Our s sub 6 now, s sub 6, this will be equal to n all over 2 multiplied by a sub 1 plus a sub 6. Okay, so s sub 6, this will be equal to our n is equal to 6. So n will be 6 divided by 2 multiplied by our a sub 1 is 1/2 plus our a sub 6 is positive 3. So our a sub 6 is positive 3. S sub 6 will be equal to 6 divided by 2 is positive 3, and multiply this by 1/2 plus 3. Okay, so 1/2 plus 3. To make this as a fraction, this would be 3 over 1. Okay, so S6 will be equal to 3 multiplied by, okay, 2 and 1. The LCD is 2. 2 divided by 2 is 1 multiplied by 1, that is 1. And this is plus 2 divided by 2 is 2. 2 times 3 is 6. Our S6 will be equal to 3 multiplied by 7 over 2. And our final answer here will be 3 multiplied by 7, that is 21 all over 2, or for our whole number, 21 divided by 2, that will be equal to 10 and 1/2. So our S6 now, or the sum of all arithmetic terms of the given, is 10 and 1/2. And this is our final answer. Solve for the sum of consecutive integers from positive 1 to positive 70. So our formula for solving the sum of arithmetic sequence, we have s sub n equals to n all over 2, and multiply this by the first term a sub 1 plus the last term a sub n. Okay, now basing from our problem, we have consecutive integers. So when we speak of consecutive integers, these numbers are positive 1, 2, 3, 4, and so on until the last integer, which is positive 70. Okay, so basing from our given, our n here, or the number of integers or the number of terms, we have 70. And then our a sub 1, or our first term here is positive 1. And our a sub n, or the last term, this can be written as a sub 70. Our last term is positive 70. So using this equation, s sub n equals to n all over 2 multiplied by a sub 1 plus a sub n. We can rewrite this as s sub 70 equals to our n, again that is 70 divided by 2, and multiply this by our first term, which is positive 1, plus our a sub 70, which is 70. S70 will now be equal to 70 divided by 2 is 35, and this will be multiplied by 1 plus 70, that is 71. So 35 multiplied by positive 71, we will have here 2,485. So the sum of all our terms is S70, and this is 2,485. And this is our final answer. Solve for the sum of even integers from positive 2 to positive 80. So our a sub 1 here will be positive 2. And since the given are all even integers, they are all divisible by 2. So from 2, this will be followed by positive 4, positive 8, positive 10, and so on, with the last integer value as positive 80. So this will be a sub 1, a sub 2, a sub 3, a sub 4, and 80 here. This is our last term. Let's call this first as a sub n. We do not know yet the value of n. So let us find for the value of n. Our n here, which is the total number of terms. So we can find for the value of n, we have here 80 as the last term. So since all the integers are even integers, they are divisible by 2. So to find for n, we will just divide 80 by 2. So 80 divided by 2 is positive 40. This is our n. So since we now know the value of n, we can put 80 here. This 80 now will be a sub 40. Okay, so this will now be a sub 40. Let us now find for the total sum of all the terms. The formula for the total sum is S sub n equals to n divided by 2. Multiply this by a sub 1 plus a sub n. Our n, again, our n is 40, so this will be S sub 40. Okay, n here is 40 divided by 2. And our a sub 1 is positive 2. And a sub n, okay, that is 2 plus. So 2 plus, instead of n, this will be a sub 40. But we know that a sub 40 is positive 80. S sub 40 here will be 40 divided by 2, that is 20. Multiply this by 2 plus the value for a sub 40 is 80. S sub 40, this will be equal to 20 multiplied by 82. So therefore, our S sub 40 now will be equal to 20 multiplied by 82, and this will give us 1,640. Again, our sum of all terms, or S sub 40, is 1,640. And this is our final answer. Solve for the sum of multiples of positive 2 from positive 10 to positive 60. So basing from the given, our first term will be positive 10. And since all the terms are multiples of 2, so all the numbers here will be divisible by 2. Positive 10 will be followed by positive 12, positive 14, positive 16, and so on until the last term is positive 60. Our positive 10 here, this is our a sub 1, or the first term. 12 will be the second term, or a sub 2, 14, a sub 3, a sub 4. But for 60, we do not know its number of term, So we have to call this first as a sub n. We need to find for the value of n, or the number of terms. So to find for the number of terms, n here will be equal to, the maximum value is 60 and the minimum is 10. So what we need to do is that we need to subtract 10 from 60. Okay, so 60 divided by 10. And then since they are all multiples of 2, we need to divide them by 2. Okay, so 60 minus 10 divided by 2. But since we have to include also positive 10 in the counting of terms, so we need to add, from the result of this, we need to add 1. Okay, so this is now our value for n. By solving, we will have 60 minus 10 is 50 divided by 2. This is 25 plus 1. So our n is positive 26. Since we now have the value for n, and we have a sub 1 and a sub n, we can now find for the sum. The formula for the sum is s sub n equals to n divided by 2 plus, or rather multiplied by, so this is multiplied by n sub 1 plus n sub 2. Okay, but we now know the value of n. So s sub n instead of n, this will now be s sub 26 equals to our n, 26 divided by 2 multiplied by our a, rather this is not n sub 1 but this is a sub 1. Okay, again this is a sub 1 plus a sub n. Okay, so we know the value of a sub 1 is positive 10, so this will be 10 plus a sub n. This is now a sub 26. S26 here will be equal to 26 divided by 2, that is 13, multiplied by 10 plus our A26. Okay, so 60, this is also now equal to a sub 26. So a sub 26 is 60. Therefore, s sub 26 now will be equal to 13 multiplied by positive 70, or this will be equal to 13 multiplied by positive 70. This is 910. So therefore, the sum of all terms for our given problem is positive 910, and this is our final answer.